we've talked a little bit about the nucleus. We know about protons and atomic number and neutrons and protons and mass number. We really are also interested in how many electrons are around the atom. Well, it's equal to the number of protons, but also how they're arranged. Okay? And there was a guy named Niels Bohr who did some experiments and figured out that electrons are not just randomly orbiting atoms. They're in actual little energy levels around the nucleus, and they can move between energy levels, and it takes energy to do that. Okay, so electrons are not just random. Electrons move in energy levels. Okay, they move in energy levels around the nucleus. Okay. Now we're going to simplify these things, and we're going to draw them as rings. Okay, so here's a nucleus, big solid center of the atom. Okay, there's no electrons in there. Rather, the electrons are actually found in energy levels, and we draw energy levels as rings, but the rings don't overlap, so I'm going to fix that. Okay, we draw energy levels as rings, okay, and electrons can jump back and forth between these energy levels. Okay, it's not a big deal. You add energy to an electron, and it moves from here up to here. You add a little bit more energy, it can move from here to here. You add a whole bunch of energy at once, it goes all the way up. Okay. But the protons in the middle are positive, right? And they're pulling these electrons back, and so these electrons fall back down to lower energy levels. Okay? And when they do that, since energy can't be created or destroyed, they have to give off that extra energy, and they give it off as waves of light. And depending on how much energy they lose, they might give off red light or blue light or green light. Okay? And that's actually how Niels Bohr discovered these electrons move in energy levels. He looked at the colors of light produced and was able to determine energy. Okay? Now, if you take a look and you notice, this is the first energy level, this is the second energy level, this is the third energy level. I could draw another ring around the outside, okay, and I could get up to a fourth energy level. Again, they don't overlap, but you get the idea. Okay. If you look, the first energy level is kind of small, the second energy level is bigger, the third energy level is bigger still, the fourth energy level is bigger still. Okay. And that reflects that they can each hold more electrons. Okay, the first energy level can only hold 2. The second energy level can hold 8. The third energy level can hold 18. The fourth energy level can hold 32. Okay, but it doesn't just stop there. Okay, energy levels contain orbitals. Okay, and this is where the electrons really move. Energy levels contain orbitals. Orbitals are regions of space. It sounds like orbit, okay, but instead of just a circular orbit like a planet around the sun, it's a three-dimensional, goofy-looking blob. Okay, so orbitals are regions of space where electrons are likely to be found. Okay, and you can get pretty complex in here and do some probability and some math and know more about it. If you want to do that, cool, take chemistry. Orbitals are regions of space where electrons are found most of the time. Okay, and so we don't have to know a whole heck of a lot about orbitals, except electrons don't like each other. They're negative charge, same charges repel. So orbitals only hold 2 electrons. Each orbital can only hold 2. Okay, so orbitals each hold 2 electrons. Okay? After that, they won't take any more. So you've got to have multiple orbitals if you're going to have more than 2 electrons. And since we need more than 2, right? Hydrogen has 1 electron, helium has 2 electrons, but lithium has 3. It's going to need another orbital. Okay, not a big deal. We just go to another energy level. Okay? And so there's this relationship. Each energy level, that's not how you spell level. Each energy level holds a different number of orbitals. Okay, and really what I want to say here is each energy level holds n squared orbitals, okay, where n is the energy level. And what I mean by that is, say we're talking energy level 1. I'm going to go ahead and draw a chart. So I'm going to have energy level, I'm going to have orbitals, and I'm going to have electrons. Okay, energy level, orbitals, electrons. Okay, energy level 1 has 1 orbital because it's 1 squared equals 1. Okay? And since every orbital holds 2 electrons, 2 times 1 equals 2. Energy level 2 holds 2 squared orbitals, which equals 4. But that means it'll hold 8 electrons because each orbital holds 2, so 2 times 4 is 8. Okay, energy level 3 holds 9 orbitals because 3 squared equals 9, but that means it'll hold 18 electrons. 2, 8, 18. Okay, so this pattern repeats forever and ever and ever and ever and ever. So if we're talking about the nth energy level, then it would hold n squared orbitals, and that would be 2n squared electrons. Okay? You don't have to memorize that formula, but it's important that you know that the energy levels each hold a different number of electrons. The inner one holds 2, the next one holds 8, the next one holds 18. After that, okay, if you need more, you can draw it out based on this formula. You're never going to have to draw it out for me, but you will occasionally have to draw some smaller atoms. Okay, and so when you're drawing atoms, you always need to know how many particles there are, and then you can figure out their arrangement of everything. Okay, so I'm going to pick an element. I'm going to pick silicon, and I'm going to pick silicon 29. Okay, and that's a specific isotope of silicon, and that means I can know how many protons it has and how many neutrons it has and how many electrons it has. So I want to find all that information: protons, neutrons, electrons. And to get that information, all I have to do is look at a periodic table. Okay, and so here's my periodic table. Here's silicon. Okay, silicon is element number 14. Okay, that tells me it's got 14 protons and also 14 electrons. So over here, I'm going to go ahead and I'm going to record that: 14 protons, 14 electrons. Neutrons, how do I get neutrons? Well, 29 is the mass number. 29 minus 14 is 15. Okay, so I've got 29 total things in the nucleus. 14 of them are protons, that's why it's silicon. 15 of them are neutrons, and since the electrons and protons balance, I've got 14. Okay, so then it's time to draw the atom. At the center of every atom is the nucleus, and in every nucleus there are protons, so I've got 14 protons. In this isotope of silicon, there are 15 neutrons, so I write N15. Now, these are actually little particles, but I'm not going to count 29 little particles. Okay, you're just going to tell me 14 protons, 15 neutrons there in the nucleus. Electrons don't go in the nucleus though, so I can't start adding electrons yet. So I need an energy level. Okay, so I have my first energy level. I need a total of 14 electrons, but remember the first energy level only holds 2. Now it's full. I can't put any more in there. They won't fit. So I need another energy level. So I draw another ring. Okay, I need a total of 14 electrons. I have 2. That means I need 12 more. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, well that gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total electrons. But I can't put any more electrons in this second ring. The second ring only holds 8. Okay, the second energy level holds 8. So I need another energy level. Okay, and so my last energy level can hold 18 here. I don't need 18. I've got 2 in the middle, right? I'm going to circle that. I've got 8 here. That's 2 plus 8 is 10. I only need 14. I only need 1, 2, 3, 4 more electrons. Okay, and so now I have it. Now I have 14 electrons, 14 protons, and 15 neutrons. I have silicon 29. Now I want to show you something. Okay, there's a quick double check on this, and it all comes from the periodic table. Okay, so I'm going to grab my periodic table, I'm going to drag this in, I'm going to look at where silicon is located on the table. Okay, if you look, silicon is this element right here, element 14. I'm going to count down the rows. Helium's in row 1, neon row 2, argon row 3, here's silicon in row 3. Okay, now if I go back to my atom, it's got 1, 2, 3 energy levels. Okay, and that's the way the periodic table is set up on purpose. The row number of an element is the energy levels that it has. Okay, so silicon I knew was going to have 3 energy levels based on its location in the table. Okay, but there's more. Okay, there's one more thing I can get. Okay, these first 2 columns and these last 6 columns are called the A group elements. This is column 1, column 2, column 3, 4, 5, 6, 7, 8. everything in these columns has the same number of electrons in the outer energy level as the column number. For instance, silicon is in column 1, 2, 3, 4. Here's silicon. Well, that makes it in the fourth column. That means it should have 4 electrons in its outer energy level, which I know is the third one. Okay, and if I look, it's got 1, 2, 3, 4. Okay, and so that's the last thing I'm going to tell you guys on this one is the row number on the periodic table actually shows you the energy levels. Okay, rows run horizontal, left to right. Row number is energy levels. Okay, so if it's in row number 7, it has 7 energy levels. If it is in row number 3, it has 3 energy levels. Okay, and column number, the A group column number, is electrons in the outer energy level. Okay, and if you can keep those two things straight, you can always double check yourself. Okay, so if I wanted you to draw a bromine atom, and I don't want you to draw a bromine atom, it's way too big. Okay, here's bromine. Bromine's element 35. It's in the 1, 2, 3, 4th row. Okay, so I know it's going to have 4 energy levels. This is column 8. This is column 7. I know bromine's going to have 7 electrons in the 4th energy level. Okay, it's going to have more in the 3rd energy level, and more in the 2nd energy level, and more in the 1st energy level. But in the outer energy level, there's 7 electrons, and the outer energy level is the 4th energy level.